Good morning, class. Welcome to another week of our class PLBC Virtual Classroom Simulation. I still remain Mr. Sharif Abdul Aziz. Today we are going to look at another topic in our scheme of work, which is differentiations of algebraic functions. First of all, what do you mean with differentiation? Differentiation simply means to find the process of finding the derivatives of a function. The process of what? Finding the derivatives of a function. So, or we simply means the process of finding the differential coefficients. The process of what? Finding the differential coefficients. That is what we mean with differentiation. And under this differentiation, we are going to look at some aspects that as a student you need to know. First of all, you need to know how do you substitute the limit functions. How do you substitute what? Limit function. And at the end of this topic, you should be able to know how to find the derivatives of a function using first principle. You should be able to know how to find the derivatives of the function using standard derivatives. You should be able to know how to find the derivative of a function using product rule, chain rule, or even the quotient rule. And we are going to look at some simple application of differentiation to our real life situation. So now, let's start with the limit. The limit. How do we take the limit of any functions? There are simple rules that you should know under this limit. I listed some rules like this. The limit, for instance, you have a fraction and you are asked to substitute a limit. The limit simply means substitutions. How do you substitute the value that they gave you in a given function? For instance, if they say limit of x tends to 0, means x is approaching 0. So in your function, wherever you see x, you put 0. Wherever you see x, you put what? 0, since it's approaching 0. So 0 over 2. 0 divided by 2 is what? 0. We know that in our simple algebra that 0 divided by any number is 0. So it's 0. So if you take limit of x tends to 0, 2 over x, for instance, when you substitute the limit, it's going to be 2 over 0. So 2 over 0 under the limit function is infinity. Is what? Infinity. It's no longer undefined, as you normally used to say. So it is what? Infinity. Then if you take the limit of x tends to infinity itself, so x over 2, when you substitute the limit of x tends to infinity, anywhere you see x, you put infinity, right? So we are going to have infinity over 2. That means infinity over any number. Infinity over any number still remain infinity. I hope we are getting it. So now, if you take the limit of x tends to infinity, a number divided by x, here we just use 2. So 2 divided by infinity is going to give you 0. That means you should take it at the back of your mind. Any number divided by infinity is equal to 0. Are we together? Then limit of x tends to 0, 2x over x. If you substitute x tends to 0 here, if you put 0 here, 2 times 0, 0. If you put 0 here, 0 divided by 0 now is undetermined. So any case that you have 0 divided by 0, then you are going to take it as undetermined. Then you are going to apply any other method, either by factorization. If it is a root, you apply rationalization. That is understood. If it is algebraic expression, you can just factorize and substitute the limit. So example now, take A. We are asked to substitute the limit of x tends to 2. Limit of x tends to 2. So we are going to have x tends to 2 into x squared minus 4x plus 3. It's simple as that. So just take it as anywhere you see s, you put what? Anywhere you see s, you put 2. So substitute it here. So what are you going to have, class? 2 raised to the power of 2 minus 4 times 2 plus 3. Are we together? 2 squared, 4 minus 8 plus 3. 4 minus 8 is minus 4, right? Minus 4 plus 3 is what? Minus 4. So that is the limit. Is that clear? I hope you understand it. B. Substitute the limit of x tends to 0 minus 2x squared plus 3x all over x. So what do you observe? If you substitute the limit of x tends to 0 in this function, what are you going to have? Put 0 here. What do you have? Minus 2 times 0, 0. 3 times 0, 0. 0 plus 0, 0. If you put 0 here, it's going to give you what? 0 over 0. Do we leave it like that as 0 over 0? No. as I said, when you have 0 over 0, it's undetermined, right? So you are going to proceed. So which method can we apply here? You can factorize. You can what? Factorize. What is common here? What is common at our numerator here? X. X is common. Factorize it outside. So what are you going to have left? Minus 2x. You know it is x squared here. So minus 2x plus what? 3. All this over x. Are we together? So since you have already factored x outside, can this x go with this x? Yes. What do you have left? Minus 2x plus 3. So now put the limit. Limit of x tends to 0 of minus 2x plus 3. So what are you going to have? Anywhere you see x now, put 0. Is it going to be undetermined again? No. So substitute it. Whenever you see x, you put 0. So you're going to have minus 2 times 0 plus 3. Minus 2 times 0 is going to give us what? 0. 0 plus 3 is equal to 3. So the limit of x tends to 0 now is going to give us 3. Are we together? Then if you pick the next one, limit of x tends to 2, we have x squared minus 4 all over x minus 2. What do you observe now? Put x is equal to 2 here. 2 squared is going to give you what? 4. 4 minus 4, 0. If you put 2 here, 2 minus 2, 0. What do you observe? It is what? Undetermined. So what are you going to do? We proceed by either factorization. So how do we factor our numerator here? Factor your numerator. You can apply difference of 2 squared. Are we there? Difference of 2 squared, this is something as x squared minus 2 squared all over x minus 2. This 4 is the same thing as 2 squared, right? So now what are you going to have? Difference of 2 squared is going to be what? X minus 2, x plus 2. Are we together? All this over x minus 2. Class, are we together? So this one can go with this one. Is it true? What do you have left? X plus 2. So therefore limit of x tends to 2 into what are we substituting now? X plus 2. We have substitute it and see. If you put x tends to 2 now, what do you have? 2 plus 2 is equal to 4. So simple as that. So that is how we substitute the limit of any given function. Any problem? Thank you. Now if you have a function, y is equal to x squared minus 4. So the simple way of finding this using first principle is we do what we call addition of increments. Addition of what? Increment. Because it's a curve. It's a what? It's a curve. You know quadratic curve, the way it used to go up, right? So that is the same thing here. This is a quadratic function. So it's a curve. It's going up. So since it's going up, as x is increasing, definitely y will be increasing. As x is increasing, y will be what? Increasing. So what is the increment of x? The increment of x is x plus delta x. X plus what? Delta x. And the increment of y is y plus delta y. These are the two things we need. Increment of x is x plus delta x. Increment of y is y plus delta y. So for you to use first principle, anywhere you see x, just put the increment of x. Anywhere you see y, just put the what? Increment of y and substitute. Simplified. Like in this case now, we have y is equal to x squared minus 4. What is the increment of y now? Anywhere I see y, I will now put what? Y plus delta y. Are we together? Is now equals to x. What are we going to put? X plus delta s. But it has square, right? So x plus delta s, we now put square. Minus 4. Because x plus delta s is for only x. It's for only what? X. Had it been here, it's raised to the power of 3. What are you going to put? S plus delta s raised to the power of 3. I hope you understand what I'm saying. Had it been, it is ordinary x. Are you going to put any power? No. You just leave it like that. So now what are you going to have from here? Y plus delta y is equal to, expand this. S plus delta s all square. Simple expansion is going to give you what? X squared plus 2x delta x plus delta s all square. If you expand this, normal expansion, s plus delta x and what? S plus delta s. Can we record this? X times x, x squared. S times delta x, x delta x. This times this, x delta x. Delta x times delta s is delta s all square. Okay? Good. So from here now what do you have? S plus delta s plus s delta x will give us 2s delta x plus this. Minus what do you have now? 4. What is the next thing you are going to do? The next thing you are going to do here is to make y the subject. And delta y the subject, Delta y the subject. So it's going to be what? Delta y is equal to x squared. Just copy this. plus 2x delta x plus delta x all square minus 4. Class, what am I going to have? When you are making delta y the subject, you know you are going to take y to the other side. So it's going to be minus what? Y. Are we together? But what is the value of y initially? The value of our y is x squared minus 4. Substitute it back there. So it's going to be what? Delta y is equal to x squared plus 2s delta x plus delta s all squared minus 4 minus y. What is our y initially, class? X squared minus 4. The minus will go through. So it's going to be, this one will be what? Minus x squared. This one will be what? Positive 4. I hope you understand what I did. Because the minus, this minus y, minus will go through. So this is minus x squared, minus minus here is plus. There are some that can cancel here. Which one and which one can go? X squared minus s squared, have they gone? Minus 4 plus 4, have they gone? What do you have common here? Delta x is common. Factor it outside. So what do you have? Delta y is equal to, what is common? Remain what? 2x plus delta x. Do you see what I did here? Because now we have only one delta x here. So divide both sides by delta x. When you divide both sides by delta x, this will go. Do you see it? Now what do you have? Delta y, delta x is now equals to 2s plus delta x. So from this stage, you take the limit. Thank God we just finished explaining the limits now, right? You now take the limit of delta x tends to 0. And as you take the limit of delta x tends to 0, this delta y delta x will now turn to dy dx. This one is writing in delta y and delta s, right? So from this stage, it will now turn to what, class? It will now, instead of delta y delta x now, it will now be what? Do you see the way I write my d now? Complete d, right? dy dx is now equals to, oh yeah, substitute delta s is 0. It means anywhere we see delta s, we put 0. Are we together? So now when we put delta s is 0 here, what do you have left? 2x. So the answer is equal to 2x. Simple. So dy dx is equal to 2x. Now if you want to find any other one here, that is the same procedure we are going to use. If you want to find this one, just substitute y plus delta y minus 6 into s plus delta s all square. I hope you understand. You expand it, you multiply it by minus 6, you collect the right terms, then you find delta y, delta x, substitute their limits. Do you understand the concept? So that is how we find the differentiation from first principle. So now the standard derivatives of some basic functions. If you have a constant, this c is representing constants. So if y is equal to any constant, what do you mean? The constants are if you have 1, 2, 3, 4, 5, any number without any variable is a constant. So if y is equal to c, its dy dx will be equal to 0. So differentiation of any constant is equal to 0. Are we there? So differentiation of x, a single variable. Differentiation of x is always equal to 1. I hope you understand. So any value of x with a power, differentiation of x raised to the power of n, any power. So it's going to be what? Nx, look at the way we have it. X raised to the power of n is equal to nx, that means the power will multiply x. Are we together? The power will multiply x and the power will reduce by 1. So that is why we see nx raised to the power of n minus 1. In fact, this is serving as the general formula of any differentiation. Of any what? Differentiation. X raised to the power of n is nx raised to the power of n minus 1. Now, what if I have any coefficient there? If I have maybe ax raised to the power of n, any coefficient, right? So the same n will multiply with whatever you have there. That is why you have a n x raised to the power of n minus 1. It's the same thing with the above, right? So this is exponential x. It's read as what? Exponential x. So differentiation of exponential x is always exponential x. It remains like that. Are we together? Then ln x. This is read as what? Ln x. So differentiation of ln x is the same thing as 1 over x. Look at the way I write it. ln. Not ln like this. If you are writing this, it's different thing you are writing. I hope you understand. This is read as ln x. So the differentiation of ln x is equal to 1 over x. Then sin x is equal to cos x. Then cos x is equal to minus sin x. I hope you are getting it. So tan x is equal to sec square x. The differentiation of tan x is sec square x. So n root of x is equal to s raised to the power of 1 over n. So According to law of indices, this is written as s raised to the power of 1 over n. I hope you know that. So this one now is our power. So that means if you have this, you have to differentiate it. As we said, the power will multiply the function. Do you see it? It multiplies the function and it will reduce by 1. So 1 over n minus 1. Are we together? So now let's take the example now. Find the y dx if now find the y dx, number 1, as our example 3, right? If y is equal to 2x raised to the power of 7, and you are asked to find the y dx. Going by this our formula, what are we going to do now? Just says your dy dx is equal to 7 will multiply 2. Are we together? 7 will multiply 2. So 7 times 2 is equal to what? 14. Right? 14x raised to the power of 7 minus 1. Class, do you understand what I'm doing? Or let me simplify it bit by bit. 7 times 2, we said 7 will multiply 2. Then x raised to the power of 7 minus 1. So what is our answer now? 7 times 2 is what? 14, x raised to the power of 6. That is our dy dx. Simple as that. Are we together? So if you take number 2 now, y is equal to cube root of x. Class, how am I going to write cube root? This can be written as what? X. This implies y is equal to x raised to the power of, what is cube root of x? 1 over 3. Is it? So how am I going to find the dy dx now? Dy dx is now equal to, 1 over 3 will multiply back. Is that? So it's going to be what? 1 over 3x. Class, are we together? So it's now going to be 1 over 3 what? Minus 1. Is that clear? So what is your final answer now? Therefore, your dy dx is now equal to 1 over 3x raised to the power of 1 over 3 minus 1 is certain as what? Minus what? 2 over 3. Is it true? 1 over 3 minus 1 is certain as what? Minus 2 over 3. So this is our dy dx. Any question? Are we getting it? So now, if you pick the next one, which is y is equal to the polynomial function, we have minus 3x raised to the power of 4 plus 6x squared minus 8. So you are going to differentiate it term by term. Each term, you just differentiate it. That is all. So now what is our dy dx, class? I think it's straightforward, right? Well, let's differentiate this one. This is coming back. It's multiplying this. What are you going to have? 4 times minus 3 minus 12x raised to the power of 3. Is it true? Because 4 times minus 3 is minus 12. So 4 minus 1 is 3. Plus, if this one come back, it's going to be what? 12x. I hope you understand how we get 12x. Because 2 times 6 is 12. 2 minus 1 is 1. You don't need to put 1 here. It's just 12x. Are we there? Minus, what is differentiation of 8? Minus 8. 0. Because we said differentiation of any constant is 0. So you don't need to put 0. Any problem? Do you get it? Good. So now that is how we find the differentiation direct. Someone can now go and test. Why is that question we solve using first principle? We said y is equal to x squared. Is it minus 4? If you are to differentiate it, what are you going to have? Dy dx is equal to, this is coming back, right? What are you going to have? 2x. Differentiation of minus 4 is what? So what is our answer? 2x. Is it the same thing with this? So that is it. So that is some differentiation from standard derivative. I hope it's clear. Thank you. Now, since we have looked at the standard derivatives, we are going to look at some rules of finding the differential equations. For instance, now we are going to look at chain rule, product rule, and the quotient rule. When do we apply chain rule? We apply chain rule whenever you have a power. The power that is 2, 3, or more than that. Or you have a negative power, or you have a fractional power. Whenever you have any power, then we apply what we call chain rule. So in that case, if for instance you have y is equal to ax plus b raised to the power of n, this n can be positive, it can be negative, it can be what? Fraction. So what you just need to do is you let whatever inside your bracket to be any variable. Here I let it to be u, for instance. I now differentiate it. You now find the u dx. After you let it to be something, you now differentiate it. Then if you have let it to be u, for instance, what will be your y now? Your y now will be u raised to the power of n. Your y now will be u raised to the power of n. Then you now find dy du. So you know you let something to be u inside the bracket, you differentiate it, you have your y. Then you now multiply them together. So dy dx is equal to dy du times du dx. That is all about the chain rule. You let it to be something, you differentiate it. Then you multiply them together. So product rule. From products, they are multiplied together, right? The two functions or more. If the two functions are multiplied together, for instance, if y is equal to uv, the first one is u and the second one is what? V. So now we have the formula to be dy dx is equal to u dv dx. What do you understand with u dv dx? We keep the first one, we differentiate the second one. The second one means dv dx plus v du dx. We keep the second one, we differentiate the first one. We just add them together. That is our product rule. U dv dx plus v du dx. Now, quotient rule. What do you mean with quotient? Quotient means what? Division. Whenever you have division, like if y is equal to u over v, numerator and denominator. So the numerator is u and the denominator is v. So now dy dx is equal to v du dx minus u dv dx all over v squared. So these are the formulas we use under these three rules. So for instance, if y is equal to 4x plus 6 raised to the power of 4, what did I say we are going to do? We let whatever inside the bracket to be any variable, right? So we let it to be u. Let u is equal to 4x plus 6. If we let it to be u, we cannot find our du dx. We cannot find our what? Du dx. So what is our du dx class? We just finished differentiation now, right? What is du dx? Differentiation of 4x is what? 4. Simple as that. Differentiation of 4x is 4. Because if you have power of 1 here, go 1 times 4, 4. 1 minus 1, 0. X raised to the power of 0 is what? 1. So differentiation of any function like this is equal to. So if I have differentiation of 3x, what is the answer? 3. Differentiation of x, we say is what? 1, and so on. Okay? Good. So now differentiation of 4x is what? 4. Differentiation of 6 is what? 0. We don't need to write it, right? So that means the u dx is 4. So if u is this, what is our y now? Y now is u raised to the power of 4. Are we together? So now this is now going to be dy du. What is our dy du now? We differentiate this. Yeah, let's differentiate this. It's going to be what? 4 u raised to the power of 3. Is it like that? 4 is coming back, then 4 minus 1. So 4 u raised to the power of 3. Are we together? So what do we say is the formula? Dy dx is equal to dy du times du what? Dx. We are going to multiply them together. What is our dy du? 4u raised to the power of 3 times. What is du dx? 4. So all in all is what? 4 times 4? 16. U raised to the power of 3. Are we together? So just substitute your u back. What is our u? What do we let it to be initially? 16 into 4x plus 6 raised to the power of 3. Do you know the reason why you must substitute it back? If you are using u, maybe your colleague may be using t, right? So you have to substitute it back. It's not necessary that everybody must use u. You can use any alphabet you want. Is that clear? So you substitute it back. So that is how we find the differentiation using function of a function. 2. If y is equal to this and this. So now what are we going to do now? This is which one? Is it quotient rule? No. Is it function of a function or chain rule? Chain rule is the one we call function of a function. Is it chain rule? This one, is it chain rule? No. It is two functions that are multiplied together. So it's what? Product rule. So in that case, what is our u, what is our v? The first one is u, the second one is what? V. Class, are we together? The first one is u, the second one is v. So what is my u? Just bring them out. Our u is what? X squared plus x. Then we can now find our du dx and keep it. Because we need it in the formula. Is it true? So what is our du dx? Let's differentiate this. Differentiation of x squared is what? 2x. Haka? Is it like this? 2x. Then plus differentiation of x is what? 1. Is that clear? So this is our u and this is du dx. What is v2? Our v is what? 3x minus 5. So we need to find what? dv dx. What is our dv dx? We differentiate this one. Differentiation of 3x is what? Differentiation of minus 5 is what? 0. So dv dx is 3. So what is the formula of product rule? We said dy dx is equal to u dv dx plus what? V du dx. Class, are we together? What is our u? We have it. What is our dv dx? We have it. Our u is what? X squared plus x. You just substitute it. Multiply by, what is our dv dx? 3. Plus, what is our v? We have 3x minus 5. Multiply by, what is our du dx? 2x plus 1. Soft. Just expand this. You can expand this bracket, right? X squared times 3. 3x squared plus 3x. I hope you understand this. Then plus, let's expand this. What are you going to have? 3x times 2x, 6x squared, right? 3x times 1, 3x. Minus 5 times 2x, minus 10x. Are we together? Then minus 5 times 1 is minus 5. Simplify this all. What is our dy dx now? Just simplify it. This and this, right? 3x squared plus 6x squared is what? 9x squared. Are we together? Then let's go with those with x. 3x plus 3x is what? 6x. 6x minus 10x minus 4x. Minus 4x. Then remain constant. How many constants do you have? 1. What do you have? Minus 5. So your dy dx is equal to this. Is that clear? So whenever you substitute it, you now have to simplify it. So let's take the one example under the quotient. Under the quotient, I said your numerator is always your u and your denominator is always your v, right? So bring them out. As usual, we have our u to be equal to 3x plus 2. Then we are going to find du dx. The same thing. What is our du dx of this one now? Class. 3x plus 2. Du dx is going to give us 3 only. Because the differentiation of 3x is 3. 2 is 0. Right? So what is v? V is 4x squared plus 1. So dv dx is going to be equal to, let's differentiate this. What is the value of this? 8x. When you differentiate 4x squared, 2 times 4 is what? 8. So you have 8x. The differentiation of 1 is 0. So du dx is 3, dv dx is 8x. Are we together? So which formula are we going to use under quotient? Quotient rule says dy dx is now equal to v du dx. Is it like that? Minus what? U dv dx, all this over v squared. Are we together? Yeah, just substitute it back. Just substitution. So what do you have now? What is our v? 4x squared plus 1. Du dx is what? 3. Minus, are we together? What is our u? 3x plus 2 multiply by, what is our dv? 8x. All this over v squared. What is our v? 4x squared plus 1. All squared. Because the formula is v squared, right? And our v is 4x squared plus 1. Class, are we together? Are we going to leave it like this? No. We are going to simplify our numerator, expand the brackets. This times this is going to give you what? 4x squared times 3. 12x squared, right? 1 times 3, 3. Yeah, let's expand this. There is minus there, don't forget. 3x times 8x will now give us what? Because of the minus, it will be what? Minus 24x squared. Is it true? Then remember what? 2 times 8. 2 times 8x, 16x. Because of the minus, it will be what? Minus 16x. All this over 4x squared plus 1 all square. Are we going to leave it like this? No. We can still simplify it further. Is it true? Which one can we simplify? 12x squared minus 24x squared. Are we there? Yeah, let's arrange it now. What is our dy dx now? Our dy dx is 12x squared minus this. Minus what? 12 minus 24. Minus 12x squared. Class, are we together? Then just arrange it. Minus, what is the next thing? 16x plus 3. All this over 4x squared plus 1 all square. So that is our dy dx. Now we have taken an example under chain rule. I said it's otherwise known as what? Function of a function. We are taking an example under product rule, and we have taken under quotient rule. I hope you are moving together. Good. We are going to look at the real life application of differentiation. Under that, we look at the gradient of the curve at any given point, and in cases that the gradient should be equal to a 0, or in cases that you will be asked to find the equation of tangent or equation of normal. At the same time, this differentiation has applications in velocity and acceleration. When they are given a distance, in physics, you all know what is a distance, and you all know what is a velocity. We define a velocity as the rate of change with respect to what? Time. So that rate of change is just simply differentiation. So when they gave you the distance and they ask you to find the velocity, you are just to differentiate it. That is all, and substitute the time that they gave you. And when you are asked to find the acceleration, that means you are going to differentiate your velocity, because we said acceleration is the rate of changing the velocity with respect to time. So you are going to find the derivative of the velocity you get and find your acceleration. But now, let's take this one. Find the gradient of a curve at the point x is equal to 3. How do you find our gradient? Our gradient, as we said, is change in y over change in x, which simply means dy dx. So now, differentiation of this, term by term, what do you have? X squared is going to give you what? 2x, right? Plus differentiation of 3s is 3. That is our dy dx. So what does the question say? At x is equal to 3. So substitute at x is equal to 3. What are you going to have? 2 into, just like limit, substitution. 2 into what? 3 plus 3. What do you have? 6 plus 3 is equal to 9. That's all. That means it is 9 units at x is equal to 3. B. The question said if y is equal to this, if y is equal to x raised to the power of 3 plus 3x squared minus 9x plus 5. Find the point at which the gradient is 0. What is our gradient? We say gradient is dy dx, right? So let's find our dy dx. Dy dx. Differentiate this. What are you going to have? Differentiation of this one is what? 3x squared. Is it like that? Plus differentiation of this is going to give us 6x. And this one now is going to give us what? Minus 9. Differentiation of 5 is 0. We all know that. So the question said, what are the points at which the gradient is 0? That means at which our dy ds is equal to 0. So just equate this one. 3x squared plus 6x minus 9 is equal to 0. That means it leads us to quadratic equation. Just solve the quadratic equation using any method of your own choice. So if you have to divide through by 3, what are you going to have now? Divide through by 3, this is going to give you what? X squared plus 2x minus 3 is equal to 0. What are the factors? You can go by factorization method, by factorization method, by factorization method. What are the factors of this one now? The factors are what? 3 and minus 1. Is that? So what are you going to have? Just put the factors at the middle term. You have x squared plus 3x plus at the center, right? Then you have minus x minus 3 all is equal to 0. What is common here? X is common. You have x plus 3. What is common here is minus 1. Are we there? Then you are left with x plus 3 all is equal to 0. That means x minus 1 is equal to 0, or x plus 3 is equal to 0, which means x is equal to 1 or x is equal to minus 3. So the points are x is equal to 1 or x is equal to minus 3. Is that clear? So you can use any method you want. And the other one, which is equation of tangent and equation of normal, let me just give you the formula. Equation of tangent is equal to m. M is equal to y minus y1 over x minus x1. Y minus y1 over x minus x1. Y equation of normal is equal to minus 1 over m is equal to y minus y1 over x minus x1. So what we are just expected to do here is to find the gradient. You find the gradient by finding to find the gradient, which is our m. You know we said our gradient is otherwise known as m, right? So this is our x1, this is our y1. We just did coordinate geometry. This is x1, this is y1. So substitute it. What is our gradient here? dy dx is equal to, we have 2x minus 3 when you differentiate this. So what is the value of x there? At x is equal to 3. So substitute it. At x is equal to 3. So we are going to have 2 times 3 minus 3, which is 6 minus 3 is equal to 3. And you know we said the s is certain as what? M, right? So just substitute it here. So we have m. What is our m now? 3. So we have 3 is equal to y minus, what is our y1? The question have given us 2 over x minus 3. So just cross multiplied, y minus 2 is equal to, when you cross multiply this will multiply this, you have 3x minus 9. So y is equal to 3x minus 9 plus 2 is going to give us what? Minus 7. So that is equation of tangent. And if you want to find equation of normal, you just use the same thing, minus 1 over m. Our m is 3, you just substitute it. And if you are given distance, you have to find the velocity, as I said. I will not take much problem on that, but if you go through the lesson notes, you will have example under the velocity and acceleration. So if you are given s as a distance, you are looking for velocity. You just said our velocity is equal to ds dt. You just differentiate its first derivative here, right? So if you are looking for acceleration, the answer you get with your velocity, you differentiate it again. So acceleration is equal to dv dt. That is just the difference between velocity and acceleration. If you are looking for velocity, what are you going to do? You differentiate the distance. They will give you the distance like this one, term by term, right? So they will give you time. Maybe they give you t as, the function may be in t. Maybe t raised to the power of 3 plus 3t squared minus 9t. So you then differentiate it. They will give you maybe at 3 seconds. Means at t is equal to what, Kina? 3 seconds. Means at t is equal to 3. Just like they said at x is equal to 3 here. You just substitute it there. So if you are looking for acceleration, the answer you get in your velocity is what you are going to differentiate again. I hope you are together. So what you differentiate again, you now substitute the value of the time they gave you. So that is all what you are going to look at under differentiation. We have looked at the basic concept of differentiation and the application of differentiation. So I think we are going to stop the topic here. Differentiation as compiled by Mr. Sharif Abdulaziz. Thank you.